Good morning, everyone. My name is Leah Diastero, and I am here to present to you my final defense presentation for the study entitled Enhanced Whale Optimization Algorithm for Course Timetabling. I am guided by Dr. Ariel M. Season as my internal advisor, as well as Dr. Jumri Matias, my external advisor. Throughout my presentation, I will share the findings and results of my research, discuss their implications, and highlight the contributions my work makes to the field. Without further ado, let us delve into the details of my research and the significant findings I have uncovered. Thank you for your presence and attention today. So my study focuses on solving the course timetabling problem, or the scheduling of classes. The motivation behind this work stemmed from my personal experience as a scheduler for the BSID and BSCS programs offered in our department in Bicol University. So for academic institutions, the scheduling of classes is quite challenging due to the various constraints and factors involved in the process. These constraints contribute to the complexity of the procedure. They may also face challenges such as new course additions, faculty availability changes, or unexpected events. Incorporating these changes and adjusting the timetable accordingly adds another layer of difficulty. So how does academic institution prepare and create schedules every semester? So manually, schedules are created per department and colleges for the program they offer. And then these schedules will rotate to other concerned department and colleges for assigning the subjects that they are assigned to teach in the case of service colleges. This process will go over weeks or months because of the rotation. The more convenient and practical solution is the use of software applications. Now, these automated systems utilize scheduling software and algorithms to streamline the scheduling process, increase efficiency, and improve the overall quality of schedules. One of its key features is quick, conflict-free schedule generation. This could save the academic institutions a lot of time and personal resources. But how does these systems create, or how are they created? So the answer would be through the use of algorithms. Like in this case, we have the meta-heuristics. So over the years, several meta-heuristic algorithms have been successfully applied to course timetabling problems. The choice of algorithm depends on the specific requirements of the problem and the preferences of the researcher or practitioner. Provided in the figure are the classification of meta-heuristics and specific algorithms, among which are the most commonly used approaches in course timetabling, which are the particle swarm optimization and colony optimization and genetic algorithms. It is also shown in the picture that highlighted is the WOA, which is the whale optimization algorithm. This algorithm would be the focus of this study. Okay, so whale optimization algorithm, or WOA, is a relatively newer addition to the field of meta-heuristics. It has been successfully applied to various optimization problems in different domains. Its simplicity, ability to handle continuous and discrete variables, and the balance between exploration and exploitation makes it an appealing option for solving optimization problems. So this was developed in 2016 by Seyadali Mirhalili. WOA aims to solve complex optimization problems by mimicking the social interactions and hunting strategies of whales. Its main idea is to maintain a population of whales and iteratively improve them to search for optimal or near optimal solutions. In the procedure, there are three key operators. These are search for prey, inserting prey, and bubble net hunting. Initial experiments were made to test the performance of WOA in solving course timetabling. These constraints were used to create an objective function for the solving of the course timetabling. It starts with the hard constraint and then the soft constraint that was exponentiated. WOWA was tested with smaller dataset and it works fine as shown in the table, but when tested with 400 events at least, the result starts to generate too long because of being trapped in the local optima. So in course timetabling, being trapped in the local optima means that the search algorithm got stuck in a solution that may not be the best yet. So in this case, the ideal solution is to approach zero. In effect, the algorithm keeps converging to locally optimal solutions but fails to find the globally optimal solution as shown in the figure, wherein after 2000 plus iterations, the fitness value is still stuck in 3. This means that there are still 3 violations on the constraints. Possibly some resources are still in conflict. In this slide, shown are the concepts, its sources that contributed to the development of the heuristically enhanced whale optimization algorithm, or HUOA. HUOA was applied in the course timetablings with all the findings considered from previous works identified. The mechanism of the crossover and mutation that is originally from genetic algorithm was integrated to WOA to improve its exploration and exploitation capability. As seen from the previous slide, is that it does not have that much balance when applied to larger datasets. The fairness in course timetabling was also considered as one of the goals in this study, since only very few studied the fairness in course timetabling. Okay, this is the pseudocode of the HIWAWA. So in this algorithm, the encircling procedure was removed since it was identified as the cause of the slow convergence of WOA in solving larger datasets. The procedure was replaced by heuristic mutation, which integrated the crossover and mutation mechanism. The uniform crossover has been adapted to cross the parent solution. In the uniform crossover, each gene is chosen at random from the 2 parent chromosomes. The following is a description of the fundamental working procedure of a crossover operator. So first, it will choose an individual at random from the population, identified as parent 1 and parent 2 from the current position of iteration, who will be used as parents. Second, the genes from the parent 1 are apprehended to offspring, and the genes from parent 2 are apprehended to offspring 1 and vice versa. So finally, a crossover rate of 0.5. The genes of the 2 offsprings are exchanged from one another. A crossover of 0.5 indicates on average that half of the parent solutions in the population will undergo crossover to produce spring solutions. The crossover rate determines the probability of applying the crossover during the reproduction step of the algorithm. For candidate solution mutation, an individual from the population is selected randomly. A mutation rate of 0.01 was employed in order to mutate an event or gene. This mutation rate, on average, in each component or gene in a solution, it means that it has a 1% of chance of undergoing mutation during the reproduction step of the algorithm. So it determines the probability of applying a random change to each component of the solution. Okay, so the proposed modification of the optimization algorithm for the course timetabling problem is a significant contribution to the field of meta-heuristic optimization and scheduling. Specifically, it will be significant to firstly academic institutions. The result of the study will be significant in the process of creating schedules for the academic institutions. It would help automate the timetabling process and reduce the workload of administrators while also improving the quality of the timetables. And it could be also integrated into existing course management system to provide real-time and rescheduling. For developers, it could also benefit them as it could be used as a building block for developing more advanced scheduling systems. The algorithm's modular design and flexibility make it suitable for customization and integration into various applications. For future researchers, the modified algorithm could be also used for those future interested researchers in solving similar combinatorial optimization problems. So the insights gained from this study could inspire further research into the development and application of meta-heuristic algorithm for other scheduling and planning problems.